you know what I'll do? We'll have 3 rounds of funding. I'll make the example on the fly. So we'll have founders with 10 million shares of common equity. We'll have Series A, which is going to be 2 million shares of convertible preferred with liquidation preference in dollars. Sorry, I'm writing it down. I'm going to, I might as well show it on my screen right now. Boom. Series A owns 2 million shares of convertible preferred with total liquidation preference of, let's say, $5 million. And we'll say it's convertible 1-to-1. So the 2 million shares can be converted to 2 million shares of common equity. We'll have Series B, which is, let's say, 2 million shares of participating preferred with liquidation preference of 10 million and convertible 1-to-1. And let's say mandatory conversion at an exit value of $200 million. Or, you know what? I'll do an example with mandatory conversion at the beginning of next class. So I'll remove that from here. And then we'll have a Series C with 1 million shares of participating preferred with cap with liquidation preferences of 20 million. A capped preference. So I'll just, so that we don't confuse this with convertible preferred. A capped preference equal to 40 million. And also convertible 1-to-1. Okay, so this is going to be our capital structure. We'll want to do a waterfall analysis of this. So we've got 4 stakeholders. And what we want to ask is the following: who has optionality, and when does optionality get triggered, right? So step 1, right? Maybe should I ask, like, what happens, so who converts first? I'll put converts in quotation marks. So actually what can happen first here, so first of all, will B ever convert? So B will never convert because they've got participating preferred. So we'll never need to do any calculations with regards to B. B is going to influence the equations we set up, but we know that B is never converting because they don't need to. So the first thing that'll happen will either be that Series A converts into common equity, or alternatively, participating preferred with cap, Series C, could hit their cap. Because we know that Series C will not convert until they've already hit their cap, right? So in step 1, I'm going to ask what happens first. Does A convert first, or does C hit their cap first? Right, so instead of saying who converts first, maybe I should ask what happens first. It's either A converts or C hits their capped preference. Right, this is in order to identify what can happen first, you need to kind of look at all the securities in your capital structure and ask logically what could happen first. Nothing will ever happen here because you don't need to convert. Here, you either convert. Here, you would never convert until you hit your cap. So the only 2 things that could logically happen first are that A converts this, or C hits their cap. this. So we'll figure out if A converts first, at what exit value do they convert? So if A converts first. Well, if A converts first, they need to receive at least $5 million. But what is their payoff as a function of the exit value V if they convert? So if they convert, they own 2 million shares. How many total shares are outstanding when they convert? Founders own 10 million shares, correct? Plus, Series A owns 2 million shares. But now it's important to understand the logic of what we're doing here. Is when A converts, even though they're the first to convert, we know that both B and C receive their 2 and 1 million shares respectively as participation. Even though they do not convert, they get a payoff as though they had converted. So this is important to understand, right? Plus 2, plus 1. This is participation of B and C, because B owns participating preferred, C owns participating preferred with a cap. So we know that when A converts, they own only 2 divided by 15. So 2 out of, 2 over 15 million shares. So they get that percentage of the common equity in the company. But notice, B and C are participating. So even though they get the 2 and the 1 million shares respectively, they also get their liquidation preference. So that A gets V minus 10 minus 20. Right? This is the liquidation preference of B and C respectively. Again, this comes from the definition of participation. Participation gives you both the liquidation preference and the shares. And so notice, right, when we've changed the other securities that are in the capital structure, the formula that we set up here is different. And it requires us to understand what are the other securities in the capital structure. So determining what this formula here is something you want to be comfortable doing for any combination of these 3 types of securities. Folks okay with this so far? Right? Now, once we've set up the equation, solving it is relatively straightforward. So this gives us V greater or equal to 30 plus 5 times 15 divided by 2. So that's V greater or equal to 67.5, I think. So if A converts first, and what I mean by converts first is they convert before C hits their cap, right? Then they would convert at an exit value of 67.5 million. Yes, Esteban.
Yeah, I just want to ask, so if it was the case that B and C are also convertible, preferable, then in the denominator, it would be only 10 plus 2. We would not include 2 plus 1.
Exactly. So Esteban is 100% correct. So in the alternative scenario where Series B and Series C were also convertible preferred, we would not have had this because those shares wouldn't exist, right? Here they exist as participation to the holders of participating preferred. I mean, loosely speaking, the math is as though those shares existed without you needing to give up your liquidation preference. But that's only true for participating preferred. And for participating preferred with a cap, it's only true until you've hit your cap. Right, so now let's go and figure out if, right, because the other alternative is that C hits cap first. So what we need to do is we need to figure out at what exit value of V would C hit their cap. So what is the payoff to Series C prior to hitting their cap, assuming that A has not converted yet, right? So first, meaning that A has not converted. Well, their cap is what? Their cap is 40. So they hit their cap once their payoff from liquidation preference, the liquidation preference was 20 million. Plus they participate what? They participate 1 million share. How many shares total are there if they are participating, but A has not converted yet? Well, then there would be the 10 million shares owned by founders. There would be the 2 million shares of participation of the Series B. And then there would be their 1 million shares of participation. So notice there is not the 2 million shares for A because A has not converted yet in this calculation. So while C is participating, if A has not converted yet, they have 1/13 of the common equity. What is the common equity worth? Right? It's V, exit value, minus 5 minus 10 minus 20. That has to be greater or equal to 40, right? Because if C hits their cap first, all the liquidation preference still exists because no one has converted, right? So at what value of V does this happen? So we can just, are folks okay with this equation? Or if there's something that's unclear about this, right? Let me label all this. This is the liquidation preference of C. This is the founder shares. This is Series B participation. This is Series C participation. This is A's liquidation preference, B's liquidation preference, and this is C's liquidation preference. Right, so now we solve for this threshold value of V. That gives us 20 times 13, 260 plus 35, 295. Right, so if C was hitting their cap before A converted, they would hit their cap at 295 million. So we've considered these two hypothetical possibilities. Clearly the right one is this, because you always pick the one that's the lower number. So this is telling me that the first thing that happens is that A converts into common. So now we need to ask ourselves in step 2, what is the second thing that happens? Well, we actually don't need to consider different hypothetical scenarios here, because we know that the next thing that's going to happen is that C is going to hit their cap, because C is not going to convert until they hit their cap, and B is never going to convert. So step 3 here, step 2, I think, is asking, when does C actually hit their cap? Because our last calculation had assumed that A had not converted yet when C hits their cap. But now we know that when C hits their cap, A will already have converted. So when does C hit their cap? It's when their liquidation preference plus their 1 million share of participation divided by what? 10 plus 2 plus 2 plus 1. Because now we're going to include the shares that are owned by A because A has already converted. Of what? V minus 10 minus 20 has to be greater or equal to 40. So just notice the difference between this formula here and our prior one. The difference is I added 2 million shares to the denominator here because A has already converted, but I also removed the liquidation preference of A because now A has eliminated their liquidation preference by taking the 2 million shares. So that's the difference between my C hits cap formula in step 1 and my C hits cap formula in step 2. It's because the two formulas are making different assumptions. First one assumed A had not converted. This one now assumes that A has converted because we now know from step 1 that A will already have converted. So now we solve this equation that gives us 20 times 15, 330. So we know that C is going to hit their cap at 330 million. Now, what's the next thing that happens? Again, we know exactly what the next thing that's going to happen because once C hits their cap, they eventually will want to just give up their cap and instead just take shares, right? If the company is valuable enough, they're better off taking 1 million shares than taking 40 million as their cap preference. So now our step 3 is when does C convert? Well, that happens when their payoff from conversion. What is their payoff from conversion? Their payoff conversion is going to be that they own 1 out of 15 million shares. Of what? V minus 10. Because even when they convert, Series B still has their 10 million in liquidation preference. They're never going to give it up because they've got participating preferred. That's got to be greater or equal to 40. Right? Notice I'm not adding the 20 million here in the left-hand side of the formula because once they convert, they give up their 20 million liquidation preference. Right? So they don't get it, right? So that gives us 15 times 40, that's 600, 610. So what have we determined in our procedural calculations right now? We determined A converts first. They converted at 67.5 million. Then after that, C hits their cap at 330. And then C converts at 610. Oh, I'm also realizing that I had to give us the seniority structure of liquidation preference. So I'll say seniority of liquidation preference. I'll assume C is senior to B, which is equal seniority to A. So I'll assume that in doing my payoff diagram. Okay, but now we're ready to actually jot down our entire payoff diagram for all 4 stakeholders. Maybe before I do that, I'll take the 2 questions that I have up. Esteban, your question?
That was from before, sorry.
Okay, sorry. Andrew?
Yeah, can you just explain why in the alternative one, if C hits their cap first, you also subtract 20, when in the one before, if A converts, nothing else happens. You didn't subtract the liquidity preference for
A. So C hits cap, like if C hits their cap, they were still getting like So just before hitting their cap, they were getting 20 plus 1 million shares, right? Now here, we're assuming no one has converted yet. So if no one has converted, common equity owns a piece of what pie? What's left after all the liquidation preference has been paid? So common equity in total is worth V minus 5, minus 10, minus 20. This 20 went straight into C's pocket, right? But the 5 and the 10 went to Series A and Series B respectively, right? So what's left for common equity is this. Why did we drop the minus 5 in our next calculation? It's because in our next calculation, we know that A has already converted. And if A has already converted, they don't get their 5 anymore, but they do get their 2 million shares. So that's the reasoning between the differences in these equations. So this is something that is important to get comfortable doing, is to get comfortable with setting up these equations, because that's the real, heart of doing a waterfall analysis. And honestly, it's kind of generally most folks view that this is easiest to do via example. So we're going to do more examples next lecture as well. And I have posted examples in handwritten documents on my courses as well. So hopefully that helps with getting more comfortable with this. But what I'll do now is I'll tie down all the information that we've had so far to go and figure out payoff diagrams for each stakeholder. As I said, we've got 4 stakeholders. We've got Series A, Series B, Series C, and founders, all as a function of exit value. First thing I always do is I write down my breakpoints, right? So I said the most senior liquidation preference was for Series C, correct? And they had 20 million. And then Series A and B, which had 5 and 10 million respectively, so a total of 15, was equal seniority. So my next breakpoint is going to be 35, right? So this 20 was the liquidation preference of C. 35 is the total combined liquidation preference. Then we had 67.5 million, 330, and 610. So I'll just write these breakpoints in every payoff diagram. By the way, I'm making no attempt to draw these things to scale. If you guys do an exercise like this, when you do an exercise like this on the final exam, you don't need to draw it to scale either. So long as you draw the breakpoints, you show me the slopes, I'm going to be satisfied with your waterfall analysis. All right, so now we'll just talk through the details of the payoff diagram. Well, we know Series A and Series B get nothing from 0 to 20, as do founders, because everything from 0 to 20, so a slope of 1, is going to Series C because they have the most senior liquidation preference. Then what happens from 20 to 35? A has a slope of 1/3 because they have 5 of the 15 million left in liquidation preference. B has a slope of 2/3. And then C is flat because they've hit their 20 million in liquidation preference and they're not converting yet. You might say, well, shouldn't their slope be positive because of participation? But from 20 to 35, there's nothing to participate in because common equity is still worthless because now everything is going to A and B. So far, so good? So now let's think about what happens. Oh, well, I should also mention what's happening for founders. Founders are still getting nothing. Now, what happens from 35 to 67.5? A is not converting, so they have a slope of 0. Now, what happens for B, C, and founders? Well, all of them are going to have some slope. Founders have 10 million shares, B has participation of 2 million shares, and C has participation of 1 million shares. So there's a total of 13 million shares, of which 10 out of the 13 million are owned by founders. And 2 out of 13 are owned by Series B through participation. And 1 out of 13 is participation to Series C. Now, what happens at 67.5? 67.5, now A converts. Since they convert, now they own 2 million shares as well. So now there's no longer 13 million shares. There's 15 million shares. So they own 2 out of 15 million. Two out of 15. Everyone else's slopes fall a little bit because of the dilution effect of the 2 million shares that A gets. So in particular, slope for B falls. This is really difficult to draw in a way that looks accurate, but slope falls slightly to 2 over 15 million, right? Because now there's 15 million shares out there, not just 13 million. Same thing, this slope falls slightly to 1 over 15. And then this falls to 10 over 15. And over 15 million. Now let's think about what happens at 330 million. At 330 million, C hits their cap. So actually, if you look at the level of this curve at 330, if you like drew the horizontal line like this, it would be exactly equal to 40 million. But then they stay flat. So here the slope is 0 for Series C because they have hit their cap. So until they convert, they have no shares anymore. They just have their 40 million in capped preference. So given that they have lost 1 million shares here, you kind of get the reverse of dilution for everyone else. They own now, instead of 2 out of 15 million, they own 2 out of 14 million. So the slope goes up slightly to 2 out of 14 million. This goes up slightly to 2 out of 14 million. And this goes up slightly to 10 out of 14 million. And then the final step is what happens at 610. Well, at 610, C now converts. And so they go back to having 1 million shares. So now their slope goes back up to 1 out of 15. And everyone else gets rediluted to 2 out of 15, 2 out of 15, and 10 out of 15 million shares. And this completes the waterfall analysis in this specific example. So, you know, one thing to notice from this exercise is that, you know, when you see that someone buys convertible preferred equity or something, you can't immediately know what their payoff diagram looks like, because depending on what other securities are in the company's capital structure, right, the payoff diagram can start to change. Indeed, right? Like this is convertible preferred. This looks very different from the original sketch of a convertible preferred payoff diagram that we did when we just had one round of investment. It's because all the other rounds of investment had an influence on this payoff diagram. And the influence is pretty nuanced because the way different stakeholders exercise optionality create changes in your payoff diagram where they create kinks. So we're seeing that, right? There's a fair number of kinks in this slope, right? There was a kink here because you start to get liquidation preference. There was a kink here because you've plateaued and hit your liquidation preference. There's a kink here because you convert. There was a kink here because Series C hits their cap. And then there was a kink here because Series C converts, right? So every time one of the other stakeholder makes a change in their decision or has a change in their status, they hit their cap or they convert, that creates kinks in your payoff function, usually. By the way, it can get even more complex than that, because if we throw in mandatory conversion into this problem, what we'll also find is that there's going to be jumps and drops in the payoff diagrams as well. And that's one thing we'll see in an example in class next Monday. But hopefully what you understand is as we work through this problem, and I try to explain it with words in the examples that I posted on my courses as well, is that the actual logic step by step that we're doing is pretty much always the same, right? We're asking ourselves, like, logically, what are the sets of things that could happen next? Oh, A could convert or C could hit their cap. Let's check both hypothetical scenarios and find out which one is legit. It's the one that happens at a lower exit value. And then once we've done that, let's find out, well, given that we know that this happens first, what could happen next? Or what are the sets of things that could happen next? And so we just kind of iteratively go through that logical process. And then once we've found out our breakpoints, figuring out the slopes every step of the way is really just about asking yourself the question, how many shares do I own or have participation in? And how many shares are there total? It's always the ratio between those two things. By the way, another thing you'll notice, if you take a look at all of these payoff diagrams, if you add them all up, what you'll notice is in every segment, the sum of the slopes is always 1. Slope of 0 plus 0 plus 0 plus 1 is 1. 1/3 plus 2/3 plus 0 plus 0, 1, right? 2/14 plus 2/14 plus 10/14 plus 0 is 1. You know you've made a mistake in your waterfall analysis if the sum of the slopes are not equal to 1. And it's a pretty obvious reason. Though this exercise was entirely an exercise where we're thinking about how the value gets split between all the stakeholders. In other words, right, every dollar should be distributed. So the sum of the dollars should just be equal to V. Right? So again, if you added this curve plus this curve plus this curve plus this curve, that would add up to just the curve, y equals x, right? Because the sum of the slope is always equal to 1. It's always a good trick to just double check if you've made a mistake somewhere, because if that's not happening, then you know you've made a mistake somewhere in your exercise. And this tends to be a bigger issue actually when we have mandatory conversion, because it's easier to make mistakes in figuring out how much of a jump one person gets versus how much of a drop someone else gets. Again, we'll see that via example next lecture. Are there any questions about this? Again, I think this is definitely the kind of thing where you get more comfortable the more exercises you see. So my recommendation would be look at the documents that I posted on my courses. I did try to write them in a way where it talks you through the exercise. And what I'll do is I'll make sure that the exercise I do next Monday with mandatory conversion, that it's an exercise that is not in my handwritten stuff, so that it's an incremental exercise. So it gives you guys more practice, basically.